Now what this did was that it actually divided this number 3 with the number 5. So it was something like this. So let's demonstrate this inside our comment section. So it did something in real life. We would have seen an answer, a quotient of 0.6. Now what the compiler did was it first looked into the left hand operand and it looked at the right hand operand. Then it divided the number 3 with number 5. So the first, if we do a simple math, the first we won't be able to divide um, we won't be able to exactly divide 3 with 3 by 5. So we need to take a 0. So let's do something like let's do we okay. Now when we divide this by 3, so we get something. The first quotient that we will get is 0. So when we get 0, we get the remainder. We need to replace this with the value of 0 in here. So when we use the quotient of 0, we replace it in we actually place this below the part of 0 in real life mathematics. So when we place this 0 below 3, we get the remainder of 3. And after that, the compiler doesn't actually go and print out any of the decimal values, or it does not produce any decimal values, because it looks at both the operands and it sees that we are actually using integer data types or numbers that are whole numbers. So it divides 3 by 5, and it actually takes the first remainder, that is 3, and when it takes the first remainder and it stores that remainder 3 inside the modulus of variable, and then we get the printed result when we use it inside our alert function. Now that was it about the modulus operator. Now let's see how this arithmetic precedence works when compared with the relational operators. Now let's use something like this, and let's erase this part, and why not use something like 40. So let's save this part and let's see what happens on our web page. Oh, I need to erase that part. Let's erase this part because we don't need this right now. It was just for the demonstration purpose. So we actually get the JavaScript alert box, and it's printed out the value that we wanted to on the alert box. So it's working perfectly fine. And now let's see what happens inside our browser. I mean inside our code. So what the compiler first does is that it looks at both the operators. So when it sees that it has an arithmetic operator along with a greater than or a comparison operator, so it will first prefer to use this addition operator. Now when it first tries to use this addition operator, it will actually evaluate this part first, and then it will replace this part with the value with a boolean value of either true or false, and it will then it won't actually replace it with the boolean value of true or false. I'm sorry for that, but it will actually evaluate this part, and it will replace this section with the value of 24, because 2 plus 2 is 24. So when it first evaluates this part, we get the value of 24. I guess I'm right. And when it sees, then again, it sees that it has got a greater than comparison operator. When it sees that it has encountered a relational operator, and it reads that this 40 is greater than 24. So what it reads is actually true. So because for the number 40 is actually greater than 24, this condition evaluates to true. Now when it evaluates to true, this block of code will get executed on our browser. So that was all about our arithmetic operators, and now let's move on to something different. So what if we want to use something like this? We want to use two similar type comparison operator inside our condition. So in general perspective, in general mathematics, this is true. So your high school teacher might have taught you, they may have taught you that the number 40 is greater than 24 and the number 24 is greater than 12. So you will read that this is a true mathematical notation. But is it actually true in computer programming? So let's have a look. Let's save the script and let's print this out on our browser. So our browser actually again ignores this header section, and hence it does not print out all the part inside our script. It just prints out the body section. So when it prints out the body section, what we get in here is that we need to see what happened actually. The thing that happened is the thing that the compiler encountered was that it first looked at both of these relational operators. It saw that both of these relational operators are similar. They are greater than symbols. So what would this compiler do? It will first see that both of them are greater than symbols, and hence it will start evaluating from the left. So whenever a compiler encounters something similar to this, or something similar to this situation, or if it encounters two or more similar comparison operators, it will start its evaluation process from the left. So when it starts its evaluation process from the left, it will first look at this left-hand operand of 40, the numeric value of 40, along with the numeric value of 24, that's the right-hand operand. So because 40 is greater than 24, this is a true. It will evaluate to true, the Boolean value of true. Now when it evaluates to true, it will be replaced with the Boolean value of true. After the evaluation has been successfully done, we get the value of true, and now it will then evaluate the right side, and now it will evaluate the last relational operator along with its operand. Now we have the Boolean value of true on for our left-hand operand, and a numeric integer value of 12 for our right-hand operand. So what the compiler sees is that true is greater than 12, but that can't be the case. How can true be greater than 12? Because true is a Boolean value and 12 is a numeric value, and both does not even represent a similar data type. So this part evaluates to false, and hence we don't get this alert function printed on our browser. But what if we actually wanted to use that type of code inside, or we really badly want to use something like this? In programming, what we call is the logical operators. These logical operators helps us to solve this problem that we usually take for granted in real life situations. Now in real life situation, this is true, but in programming perspective, this isn't true. That's what I've shown you right now. Now what we wanted to show that 40 is greater than 24, and 24, the lone value of 24 is greater than the value of 12. We will be using, to solve this problem, we'll be using that logical AND operator along with this 24. So now what we get in here is that 40 is greater than 24 and 24 is greater than 12. Now let's save this and see what happens. Now you see our alert function successfully produces the result inside our if condition. So this gets executed once we use this AND logical operator. Now the logical operators have the lowest precedence. Now we have three types of logical operators. The first one that I've already shown you is the AND, the second one is the OR, and the third one is known as the NOT operator. Now the logical operators, except the NOT, has got the lowest precedence in all of the operator hierarchy. It will always be evaluated at the last of a program, or at the last of a conditional, I mean not the program but of the conditional. If the compiler encounters in a single statement an arithmetic symbol, if it encounters another comparison symbol along with this AND operators, it will first evaluate this arithmetic symbol, then it will evaluate this comparison symbols, then it will evaluate this. If it encounters this identity operators, it will evaluate that identity operator, then it will look at this, and then it will start evaluating the values for the logical operators. Now we have got these three types of logical operators now, and we'll be discussing about them in this section and how they affect our program control. We'll be also discussing about that. Now the first thing that we looked at is how to use this AND operator. Now the AND operator and logical operator perhaps also takes up two operand. This is a binary operation. By binary operation I mean it takes two operands